Continuing with section 4.4, which is L'Hopital's rule, we have the statement of the theorem. So suppose that both f of a and g of a are 0, and that both f and g are differentiable on an open interval containing a. And as long as g prime of x is not equal to 0, if x is not equal to a, then what we have is this. We have the limit of f of x over g of x as x approaches a equals the limit of f prime of x over g prime of x as x approaches a. So what that is telling you is that if you have a 0 over 0 situation, as opposed to factoring or something like that, you can just take the derivative of the numerator and the derivative of the denominator. So let's do a quick example. Let's start with something that we know. So let's say I gave you the limit as x approaches 0 of sine x over x. Now this is something that we've seen before, more than once. We know that the answer is 1. We use geometry to prove that. So again, this is an indeterminate form, 0 over 0. So what I'm going to do is I'm going to use L'Hopital's rule. So to indicate that I'm using that theorem in this step right above the equal sign, that's telling the reader that I'm using the result of this theorem. So what I'm going to do is I'm going to take the derivative of the numerator and the derivative of the denominator. So the derivative of sine of x is cosine of x. The derivative of x is 1. So what we're saying is that these limits are the same. So in order to find this limit, I can find that limit. Now in this case, I can just use direct substitution. We know that cosine of 0 is 1 and 1 over 1 is 1, so this limit is in fact 1.